policies. So yes, we have discussed about serial GC, parallel GC, and concurrent mark and sweep GC and how it works and what are the different parameters to tune it, for to improve the performance and optimization in terms of reclaiming the memory. And we have seen how each and every event occurs, like initial mark phase, concurrent mark phase, remark, what happens in remark phase and concurrent sweep, and also the concurrency and what are the trade-offs. And then we discussed about G1 GC and in which version it is made as a default GC policy, how it works, and yes, yeah, what are the parameters we can enable to achieve better performance. Yeah, um, application running, application executes normally. Minor GCs can occur intermittently. So we have discussed like how exactly this works, right? These are the sequence of events that happens um, when you configure your Java heap with G1 GC. So concurrency being the main focus here, and the memory is divided into regions instead of contiguous generations. So we have discussed about this. So what are the events? Young GC, concurrent marking, remark phase, cleanup phase, then mixed GC. So when all these events are occurring in the Java heap memory, the application continues running with the minor or short uh, pauses. And we have applied a pause time. We have given a target of 200 milliseconds, which is very minute for GC events, right? So it will keep it in mind to achieve the goal, but it is not guaranteed because there are many things that happens in the background. So there may be high memory pressure, and you know uh, it depends upon the the other parameters and the load and infrastructure as well, the system resources. So let us start with you know uh, applying XMS and XMX along with a GC policy. We'll start with serial GC, parallel GC, then we'll go with concurrent mark and sweep on 12.2.1.4 version of WebLogic. And yes, the G1 GC is the default, and yeah, in JDK 11 and later versions. So we'll first see serial GC, then parallel GC, and we are going to discuss many things like all the parameters. Yes. So how do you enable GC logging and with what parameters you can append in order to get fine grain logs, GC log that you can easily analyze and find out uh, the bottlenecks, right? And so manage server, if you're starting with a node manager, how to configure, and if you are using some custom scripts, yes, we will use a custom script as well. And mostly these custom scripts are used when you have a CI/CD pipeline or you're triggering the you're triggering the start server event from external resources remotely. You are triggering. So you can also we'll also see the troubleshooting and monitoring, and if there is any issue like memory leaks or out of memory issues, then you want the JVM to automatically capture the heap dumps. You know, Why this option is used to capture the heap dump automatically? Because you never know when when the out of memory error comes up and immediately your service, the WebLogic service shuts down. You may not have the time window to capture the heap dump. So in those cases, if you configure this option, the automatically capturing the heap dump, that will be helpful. Whenever there is a out of memory issue, the heap dump will be captured. And custom scripts, or you can also pass the GC parameters via command line. So we'll see that one as well, and we'll see with an example. There are different approaches passed via command line, and inside a custom wrapper script, we can prepare our own start WebLogic script. It may be any service like a managed server or a admin server if you are working on a single domain, a single server domain for test environments. And this is a real-time log that I have configured, and it is a log, entire log. So we are going to do a postmortem to analyze and understand these all events entered into the GC log. So yeah, analyzing log events. So what is the startup phase when the full GC is happening, CMS concurrent phases, and abortable pre-clean. What are all these things when the minor GC happens, and we'll understand the sequence of events and what are the key observations uh, we can determine from this GC log, and then we'll go for ZGC. Uh, yeah, at in the once we are done with the practical understanding and analysis. So, and also we'll try to understand all the different GC types and the different GC tuning parameters, memory management enhancements. What are the experimental features? There are some experimental features how to work with this parameter, and out of memory troubleshooting, and what are the WebLogic tuning, JVM tuning example for G1 GC on JDK 11, for what is the recommended GC configuration for WebLogic, which is configured with JDK 8. These are the parameters for JDK 11, optimal for ZGC, which uses JDK 17, and what are the best practices. So this is a roadmap, and we are going to discuss each and everything. Then after we'll go for heap dump analysis. Uh, there we will understand the GC roots. We'll understand uh, how to use IBM Heap Analyzer correlating with thread dumps and GC logs. So this is one way of analyzing GC log manually. So usually, there are other third-party tools and utilities as well to analyze the GC logs. But yes, there are different utilities and profiler tools. There also we can find out the information about GC logs. So let us start with uh, yeah. So let me delete this that I have created earlier. RM RF GC logs start. Yeah. So my admin server is up and running, and here I have got two managed servers in a vertical cluster on local machine with configured with two different port numbers. So the requirement is I want to configure MS1 managed server with serial GC. Okay. So when you click on manage server one, you will find many parameters here. Out of these, click on map monitoring. So if it does not show anything, it means that your server is not started. So control start. So let us open a uh, log logs ms1.out. So it is running now. Let us confirm here. Yeah, it is up and running. So now click on the on the manage server monitoring. So you can monitor the health of all the subsystems. Example, clustering, JDBC, JMS, and whatever the services it is integrated with. And if you have a separate network channels, uh, these are the different network channels for cluster communication, broadcasting, which is using UTcast, and there is SNMP, LDAP, IIOP, HTTP. So yeah, these are the different network channels and performance. So when you see this performance, the JVM heap utilization statistics. So what is the current heap size? It is 396 MB and free 28 MB or yeah 281 MB. So heap free percentage 75 and maximum is 477. So how do we know this? So whenever you start a server, for example, I have started the admin server. If you see at the starting point, it starts the server once it gets the mentioned Java heap size, which is the default. I have not tuned, I have not changed the Java heap size for admin server. So this is a default heap. You can also see here the server startup command. This is a server startup command. Internally, it invokes to start the server, right? So 256 and 512 being the maximum. So there is no GC policy applied here. It uses the default mechanism, default GC, which is in JDK 8. So let us go ahead and tune the GC, tune the memory with serial GC. And you can also see the threads here. We have already discussed this thread dump analysis and workload, the number of completed requests and pending requests. Yeah, so you can see the JMS and JDBC, everything you can monitor here. All right. So coming back to configuration, there is a sub tab called server start, and here are the arguments. So there are different approaches for tuning the JVM parameters. So if you want to configure Java heap size and GC parameters and other parameters as well, you can directly do it on set domain env dot sh script. Uh, that will be applied on all the managed servers within your domain. And if you want to configure different set of parameters for each and every managed server, you can do it on the admin console under server start tab JVM arguments. So to apply the GC policy, which is XX. The serial GC, you can give it here. So I want to tune my heap memory for manage server 1 XMS 512 MB and XMX 750, yeah, 750 MB. That will do. So whatever you tune here, you need to check first whether your operating system has enough physical RAM or not. So there is 315 MB free and 2.3 GB is used. Okay. So now if I stop this manage server, then 512 MB will get freed up. So I have added only 750 MB. So that is a maximum heap memory that can be tuned with this free physical RAM on your VM. So you have to always keep in mind how much of free or total physical memory is available on your VM. You can also check it on using the top command here. So 313 is a runtime free heap, runtime statistics. So let us, yeah, this is the heap memory and we are enforcing the JVM, the MS1's JVM to use serial GC. So once you provide with these parameters, save it and activate the changes. So no restarts are necessary. It is dynamically applied. But I want to check how much of whether the changes that I have made on MS1's JVM arguments, it is taking effect or not. So yeah, I'm tailing the log. I'll go to servers. First of all, we'll restart the server. We'll stop it. Force shutdown now. Yes. Uh, with process ID is no longer alive. Okay. Now we'll start the server. Okay. You see here, you will see the JVM arguments. It is still 256 MB and maximum is 512 MB. But this is coming from set domain env dot sh script. This is the default. But starting WebLogic server line with line, it is invoking the Java command and it is getting the parameters from the set domain env.sh. But we have explicitly defined this one and use serial GC. So with these parameters, our server is getting started. You can see which server it is. It is MS1, right? So the changes are in effect now. The server is up and running. Click on MS1, um, server start. These are the parameters you can see here. Here. Okay. So let us tune with CMS, which is concurrent mark and sweep with few more parameters. So these are the parameters we have already discussed. This one enables concurrent mark and sweep GC, and this one enables the class unloading, we have discussed about this, meta space, and we are enforcing to use CMS initiating occupancy only parameter. So this one enables the GC to use this fraction, occupancy fraction. What does it do? When